I can't remember exactly what was requested. I'm going to throw this on here and let me know if this helps. I'm going to tell you how we derived or proved the law of sines and law of cosines. I'm not going to do the whole thing. I'm going to set you about the way. And understand, this is not the only way. This is one way. Hey, if you want to look up another one, that'd be pretty awesome. It's kind of fun. So we have our generic triangle with this sort of opposite notation. And what we did is we slapped it on a coordinate system. So this is the point C0. This is the point. Work these out. I'm doing them kind of quick. This is B cosine A, B sine A. Okay. If for law of sines, we do this. I'll start the law of sines out this way. And we'll come back and I'll show you what we do for law of cosines using the same triangle. What we did for law of sines is we turned the triangle around real quick. We said, we put B at the origin, A over here, and C over here, so that the y coordinate became, x coordinate, who cares? The y coordinate, little a, is little a sine of B. And we made the observation that this y coordinate has to be the same as this y coordinate. It's the height of the triangle. The height of the triangle isn't going to change when we put this in the origin instead of this. Prove it! Careful what you ask for. But if that's bothering you, if it bothers you that we're able to conclude that those two things are the same, come on in, we'll talk about that. It may or may not. So if those two things are the same, then the y coordinates are the same. So y coordinates same. And from there, you're essentially done. I'll leave you to recognize the details. If you don't, you better come ask. Out from that spits the law of sines. Key thing to remember with the law of sines, I think, is that the law of sines is a ratio rule, a lot like SOHCAHTOA. So the law of sines looks and feels like SOHCAHTOA, where the law of cosines, by contrast, looks and feels like the Pythagorean theorem. Let's take a quick look at the law of cosines. Over to here. What we do for the law of cosines is almost, well, not almost the same, but we use the same triangle. And we recognize that this, I'm going to muddy this up a little bit, this right here is b sine theta. That's the y coordinate. This is A, and this side right here, I'll let you work that one out, is C, which is this distance, minus this distance, which is B cosine A. So all we do is slap the Pythagorean theorem, on this triangle right here. A squared, I'll write the first step. A squared, I'll even scroll up the page right here so you can see what that first step is. I'll try to keep the triangle in there too. A squared, the hypotenuse, is equal to this, b sine of a squared plus c minus b cosine of a squared. Pythagorean theorem. Foil, manipulate, blah blah blah, rearrange, apply mad algebraic skills. I think we'll have to make that AMAS. Hopefully that doesn't mean something bad. Apply your mad algebraic skills, and that will lead you to the law of cosines. I will leave that application of said mad algebraic skills for you. But if you find yourself stuck, please do come ask.